right, so these are our notes on even and odd functions, and we're going to start by looking at some graphs. But before we do that, there's a warm-up. You can go ahead and pause the video and try the warm-up on your own, and then come back and see how you did. All right, so here are your answers to your warm-up. So there's the piecewise function graphed along with evaluating, and then here are your composition of function and its domain. If you need to pause the video and look at those, you can. All right, so let's get into today's notes. First, it says here, all of the functions graphed are called even functions. Describe in your own words, what do you think it is meant to be by an even function? So look at all those. Try it out on your own. All right, the follow-up question is summarize this question. If a function is even, then where is it symmetrical? So you should have noticed that all of these graphs are symmetrical, but they're all symmetrical over the same line. And we want to know what line that is so we can say it's symmetric over that. So if you look at this function right here, okay, if we draw a vertical line going through the origin, vertical line going through the origin, vertical line going through the origin, right? They all have, if there is a point here, it is reflected over that line, and there's another point right here. If I have a point here, there's a reflection right here, okay? So what is that line that I just drew all over? That is the line, either you can look at it as x equals 0 or the y-axis. I would say the y-axis. So if a function is even, where is it symmetric? Over the y-axis. Even functions are symmetric over the y-axis. In other words, if I were able to fold the graph in half vertically, it would fall on top of itself. Okay, looking at these are all odd functions. Go ahead and put in your own words, what does it mean to be an odd function? These functions all have symmetry too. How would you describe the symmetry of an odd function? So odd functions aren't symmetrical over a vertical or horizontal line or even a diagonal. They have what's called 180-degree rotational symmetry about the origin. So in other words, if you were to flip your paper or iPad or whatever you're watching this from upside down, it would look exactly the same. So all of these functions are odd. Where do they have symmetry? They have 180-degree rotational symmetry. About the origin. And it's not over the origin. You can't go over a point. It's about the origin. Meaning that it's turning. So if you look at all the graphs here, so there is a point 1, 1 here. So there is another point right here, negative x, negative 1, negative 1. If you look here, same idea. If there's a point here at negative 1, positive 1, there's a point right here at 1, negative 1. All right? Okay. All right, so here are some examples of odd functions, even functions that are neither. So let's look at these odd functions first here. This whole vertical section right here are all odd functions. So what you should notice is that if there's a point here, let's say, and it is the point x comma y, there will be another point right here that is negative x, negative y. So it's kind of hard for me to see an exact value on this, this particular graph, but that's what it's saying. So if 3, 2 is on the graph, then negative 3, negative 2 is on the graph, right? If 6, negative 5 is on the graph, the opposite of that is negative 6, positive 5 is on the graph, right? So you look here, like this point, let's say that's a half, 1 1/4. This is negative a half, negative 1 1/4. See that? Okay. Oh, here's a good example, right? 3, 3. Negative 3, negative 3. All right, for even functions, if you see a point on the graph, so let's say this point right here, this is the point x comma y. Then the point, this is left x, but still up y, so negative xy is on the graph. Okay, so if you look here, let's say that this is 3, negative 2.5, right? Then we have negative 3, negative 2.5 on the graph. Okay, for even and odd, or sorry, for neither functions, neither odd nor even, neither of those things happen. Okay, so neither of those things happen. Also, please don't say that odd functions are symmetric, even functions are symmetric, just nothing else is symmetric. This is symmetric, this is symmetric, this is symmetric, right? They're symmetrical, right, and they're in some way, but it's this one right here, it's symmetric right here. That's not over the y-axis, and it doesn't have 180-degree rotational symmetry. So keep that in mind. All right, so let's let's put this all together. So let's talk about even functions first, and then we'll do odd. Okay, so even functions, symmetry of the graph. This is over the y-axis. So when you're looking at the graph, like with your eyes, you'll see that there's symmetry over the y-axis. Okay. Next part, if x, y is on the graph, then what other point must be on the graph too? Negative x, y. So if right x up y is on the graph, left x up y is on the graph. And then when you're evaluating, so to figure out if a function is even or odd, what we're going to do is we're going to plug in negative x for x. We're going to substitute in negative x for x. After simplifying, if we get the original function, so if we get f of x, then we know the function's even. Okay, so after plugging in negative x, if we get what we started with, so if the function stayed the same, then it's even. Hey, we're even. We're the same. Okay. All right, next we have odd functions. Odd functions, as a reminder, there's symmetry about the origin. Okay. And then if xy is on the graph, we also know that negative x, negative y is on the graph. And then when we're trying to evaluate and see if the function's even or odd, we're going to start with the same process of plugging in negative x. Okay, now after we plug in negative x and we simplify, if we get the opposite of what we started with, then the function is odd. So if we get the same thing, same, we're even. If you get the opposite, it's odd. Okay, so now what we're going to do is we have, it says graphically determine if the following functions are even, odd, or neither by using the shape of the graph and what you know about symmetry. So we know what all of these graphs look like. We had graphed them in a previous lesson. So I'm just gonna go ahead and go through and graph all of these. This is our line with a slope of 1, y-intercept of 0. This is a horizontal line. This one right here is an upward facing parabola. I'm doing my best to make it symmetric. It is symmetric, even though mine looks crooked. Square root function, absolute value function is V-shaped. Oh my goodness, why does it look like it's moved up? Good enough, okay. Cube function, like this. And then cube root function, like that. Okay. All right, so it says we graphed them, and now I want to know if they're even, odd, or neither, all right, based on what we know about symmetry. Okay, so looking at this linear function here, it has 180-degree rotational symmetry. If I turn it upside down, it looks exactly the same, so this is odd. This one right here has symmetry over the y-axis, so this is even. It says symmetry over the y-axis, so it's even. This doesn't have symmetry over the y-axis or 180-degree rotational symmetry, so this is neither. It says symmetry over the y-axis, or it's supposed to if it wasn't, whatever, even. Number 6 has 180-degree rotational symmetry. It looks the same if I turn my paper upside down, so this is odd. And then the same thing for number 7. It's also odd. Okay. All right, next it says consider the function with Consider the function with equation g of x equals x squared plus 2, and it's graphed to the right there. Notice it's a parabola facing upward, moved up 2 from the origin. Use the graph to say if the function's even, odd, or neither. So if you look here, it's got symmetry over the y-axis, so this is even. Now it says confirm the answer algebraically. So when you see confirm algebraically that the function's even or odd, you are going to find f of negative x. Well, this is g, so we're going to find g of negative x. We're going to plug in negative x every time we see an x. So this is negative x, quantity squared plus 2. And then you're going to clean it up. Negative x squared is negative x times negative x, which is positive x squared plus 2. Now you're going to compare it to the original function. So you're going to compare it to this function right here. If you look, I got the exact same thing I started with. So yes, this is even. Check. I want you to know what opposite looks like. So the opposite of x to the 4th minus 2x cubed minus 3x plus 14. The opposite of that is negative x to the 4th plus 2x cubed plus 3x minus 14. So notice everything is multiplied by -1, not just the first term. Okay? All right, moving on to the next one. Consider this function, f of x equals -6 over x. Use the graph to say whether the function is even or odd. So if you look at this graph, it has 180-degree rotational symmetry, so this function is odd. And then we are going to confirm that algebraically by finding f of negative x. All right, so we have this negative in front, which I'm just going to stick in the numerator for now. And then I'm plugging in negative x for x, right? So I have a negative over a negative, which is positive. And if you compare this to the original, it is the opposite of what we started with. This is -6 over x, and this is positive 6 over x. So this is odd. Good? Okay, so these next one here, I'm torn with how it should be done. I don't like how it's confirmed, all of these. I don't like how it's confirmed algebraically, but look at the graph first because this is going to be on a no calculator test. So I think we should do it algebraically first and then use our calculator to confirm that we're correct. And that's what we're going to do, okay? All right, so we're going to just show algebraically that the function is even, odd, or neither. So this is f of x. I'm going to find f of negative x. So every time I see an x, I'm going to plug in negative x. Okay, so now we're going to clean that up. Negative x, quantity squared, is negative x times negative x, which is positive x squared. Negative 4 times negative x is plus 4x, and then plus 4. All right, if you compare this to the original, it is not the same and it is not the opposite. All right, it's not the same, it's not the opposite. The reason why it's not the same is because this is negative and this is positive. And the reason it's not the opposite is because x squared and x squared are the same and 4 are the same. So this is neither. This is not even, nor is it odd. Okay, now we can use our graphing calculator to, I'm not logged in. Oh yeah, no, I'm not logged into my graphing calculator. So I'm just gonna use Desmos for now until I get my calculator up and running, but it's just to see what the graph looks like. So we'll use Desmos to see what the graph looks like. So that was f of x equals or y equals, it doesn't matter, I'm gonna put y equals. And then it was x squared minus 4x plus 4, I wanna say. I think that's a good memory. Okay, so if you look at this, it's not symmetric over the y-axis and it doesn't have 180-degree rotational symmetry. There is symmetry, it's just over the line x equals 2, which is not what we're looking for. So we went ahead and confirmed that no, this is neither. There we go. All right, we're gonna do the same thing for the next one. I wanna do it algebraically first and then we'll use Desmos to show that we're right. All right, so this one is called g, so we're going to do g of negative x. So that is negative x squared minus 5. Clean that up. Negative x times negative x is positive x squared minus 5. So if you look, you got the exact same thing we started with, so this should be even. Now let's use Desmos to confirm that. I'm going to delete, 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 delete. Oops, I could have left that minus there and put a 5 here. There we go. If you look, this is symmetric over the y-axis, therefore it is even. You know what we should do is in our notes, sketch a graph of what it looks like. Just a quick sketch. So this one looks like this, so it is even. This one was moved over here. Oops, that's too close to even. So it'll go like this, it looked like that, so it was not symmetric over the y-axis. All right, last one right here, once again, doing it the same way. We're gonna do h of negative x. So we have negative x cubed minus 3 times negative x. All right, we're gonna clean this up. Negative x times negative x times negative x is negative x cubed. Negative 3 times negative x is positive 3x. If you compare this to what we had, this is the exact opposite of that. So since it's the opposite of that function, this is odd. Let's go ahead and plug this into Desmos. That's x cubed minus 3x. So we have y equals x cubed minus 3x. And you can see, yes, this has 180-degree rotational symmetry about the origin, therefore it is odd. Oh, I already forgot what it looks like. Like to do a sketch of it. Sketch, okay, it looks down and up, got it. Okay, so it looked like this, down and up, and oh, I tried, right? So this is, yes, it's odd. Okay, all right, that's it for even oddness. You can go ahead and get started on homework.